All right. Good day, my fans out there. I remain your chemistry lecturer, Dr. D.I. June. We are still dwelling on change of state. In our previous lecture, we just talked about vapor pressure. But right away, we are going to discuss on boiling point. Boiling point. As I said before, I'll be taking this gradually so that if I begin to speak on the level I know it, some of you may not be able to get me right. So I'll take it step by step by going through what I have so that I will not be able to miss steps. So listen carefully as I read my write-up and then I explain. When a liquid can not only water, could be kerosene, could be diesel, could be petrol, could be red oil, anything liquid. So when you say a liquid is heated, it is not referring to only water, please. So a liquid is a general name. So when a liquid is heated, the rate of evaporation increases. When the water is, like now, if you have two containers of water, the same volume, you keep one on the sun and you keep the other one on your stove or gas cooker and you are heating it, the rate of the heating may not be the same. So the evaporation will take place faster in the one on the stove or gas cooker than the one you place on the sun. That is the truth. So listen again. When a liquid is heated, the rate of evaporation increases and the value of the saturated vapor pressure of the liquid also rises until the temperature is reached at which the saturated vapor pressure of the liquid equals the prevailing atmospheric pressure. Let me take it again. When a liquid is heated, the rate of evaporation increases and the value of the saturated vapor pressure of the liquid also rises. This will continue until the temperature is reached at which the saturated vapor pressure of the liquid is equal to the prevailing atmospheric pressure. So when this happens, what happens? The liquid is set to boil. So when that has not been attained, the liquid cannot boil. So the liquid boils only when the saturated vapor pressure rises until the temperature that is attained is equal. So therefore, the temperature at which a saturated vapor pressure of a liquid becomes equal to the prevailing atmospheric pressure is known as the boiling point of the liquid. Let me tell you that again. The temperature at which, because you are heating the liquid, so temperature is increasing. The temperature at which the saturated vapor pressure of the liquid becomes equal to the prevailing atmospheric pressure at that material time, the water will begin to boil. That's what we call the boiling point. Boiling point. So now, the temperature of a boiling liquid will remain constant. Now, if you put water is the most common liquid we have. If you put water in a container and you put your thermometer, that is a practical example now, thermometer, and you apply your heat, you see that the mercury in the thermometer will be rising up. The moment the water started boiling and it's 100 degrees centigrade, no matter the water boils for even 2-3 hours, the 100 degrees centigrade is maintained. It doesn't go above that. That's what it's telling us here. And the temperature of a boiling liquid remains constant until all the liquid has been what? Vaporized. So if you put water in a pot or in a kettle and you heat and it started boiling, the temperature remains at 100 degrees centigrade until even the whole water will empty from the pot. It doesn't increase. So the boiling point of a liquid changes with change in the atmospheric pressure. If the pressure is raised, listen, if the pressure is raised, the boiling point will be raised. And if the pressure is lowered, the boiling point will also be lowered. Right. Now, therefore, the normal boiling point of a liquid, is defined as the temperature at which its saturated vapor pressure is equal to 1 atmosphere. I take it again. The normal boiling point of a liquid is defined as the temperature at which its saturated vapor pressure is equal to 1 atmosphere. Now, the presence of impurities, what is impurities? That if the water is not clean, it can increase the boiling point. The presence of impurities also what increases the boiling point of a liquid. Let me give an example now. If you have a distilled water, let's say 1 liter, then you have another water, 1 liter also, but not distilled water, maybe dirty water, maybe mud mixed to it, but equal volume in different containers. If you put them on your stove or on your button burner at the same time and apply heat to them, you will discover that the one with the impurities will take longer time to boil than the one that is distilled. Why? Because the impurities will impair the free flow of the molecules, and therefore it will take a longer time to boil, thereby increasing the temperature, while the one that is distilled will quickly go into boiling. So, like it, comment, please share this video, and always remember to subscribe to my YouTube channel. God bless you.